Hi, everyone. I'm Jorge, product manager at EngFlow. Very happy to be here. Thanks again, Uber guys, for hosting us. And it's really my first time here in Seattle, so I'm enjoying the time and the weather so far. And today, I'm going to be basically talking about how to leverage Bazel build data to triage and optimize the builds, right? Like that's one common topic, because if you move to Bazel, it's always like, okay, you are interested in having more optimal workflows, more optimal builds, and happy, basically, developers. And then while I was trying to do this, and sorry because I don't have that many slides, how does your build actually look like, right? Like, how do you evaluate when you have to optimize, when you don't want to optimize, or what is the limit? In some cases, your build may look exactly like this. So you can see a lot of parallelization. You see that the critical path is not having that much of a problem. And by the way, I'm using the exec log graph to basically visualize the build in a better way. And then you see this and say, okay, this is basically using the resources I have, and the drag, which is basically the amount of time that you are going to get out if you remove a node, is not creating such a big problem. I can even show that a little bit more live later, but just to show you how normally a build looks like. And of course, at the end, having this tail here is going to tell you, okay, at the very end, you are actually having a lot of issues with the dragging, but it can look actually way worse. It can also look like this, right? And why can it look like this? Because you can also have, let's say, an end-to-end test that is expecting all the other inputs and actions, and just at the end you run it, and for whatever reason, one is because you forgot to do sharding, or another reason is because you cannot do that much of a sharding, then you are going to be just waiting at the very end, and you are going to have these issues, right? So it's like just hard to optimize. But this is just to tell you, when you are thinking about optimizing, you better first know how your builds look. Now, the question that I also have is like, when we are talking about builds at a scale, you cannot go and chase every single invocation that is happening out there, right? It's like you may get the tickets from the developers and you can manage it. But then if you are actually doing more proactive work, it's going to be very challenging for you to know which invocations to look at. Let me try to show you something. Who mentioned AI is the problem? Yes. Now let me just use, in this case, Claude Code. So that was the end of my slides. And the first thing that normally people does is just telling, okay, what about just looking for slow invocations? So let me do that now. So now I'm just using the EngFlow MCP, and I'm just asking, okay, just go into the cluster, tell me which are the slowest invocations from the last 2 days so that I can start evaluating. And then it's giving me back basically these answers, right? Like it's giving me what was the wall time, the critical path, the status, the requester, and the invocation ID. So why I do this? Because I can do this also in the UI or in another place, but this is just a very common pattern, just looking for slow invocations and seeing if there is a culprit. So we have a bunch of things here, and then I say, okay, what do I need to do now? Let me try something, because here I'm talking about also tools that you may need to optimize your builds. And I'm going to hit, let me check. Yeah, this one looks good. Let me pull this invocation ID. And what this is doing at the moment, and hopefully the dem gods are going to be with me, is going to tell you the following things. So yeah, one thing that is important here is that we are using different tools. So in this case, it's just, let's say, getting the invocation, getting the profile summary. And profile summary, in this case, most of you may be very familiar with the Bazel profile, but the Bazel profile is just only telling you the piece of the client side. Since we are talking about remote execution, you are always having also the EngFlow profile, and the EngFlow profile is going to tell you more details of what is actually going on. Now it's also using the build phases, so you know what is happening in the load, analysis, and execution, looking at the cache, looking at the queuing, looking at the critical path, of course. and then looking at the slowest actions. Why looking at the slowest actions? Because basically those that are in the critical path and the slowest action are probably the ones that are the culprit of what is going on. Then you get the parallelism over time. And for parallelism over time, is just looking at how many actions we're actually running in parallel for the different phases. And then hopefully it's going to return something that is kind of useful or kind of meaningful. And this, let's say, is kind of the first flow of, okay, I identify at a slow invocation, I'm getting the artifacts and I'm getting the things that are getting like provoking that this invocation is slow, and then we are going to analyze a bit of the output. So this skill, by the way, is using like different tools that we have, but it's also using the visualization that I just showed you so that you can get the flame chart at the end. In case you're interested in using the same graphs or to enable the execution graph log, you just need those two flags to be enabled in your builds, and then you are going to get basically those artifacts. So we went into one workflow, and hopefully it's going to get an output, but then you don't need always AI to do these kind of things, right? You can also use deterministic approaches to get to this kind of information. So what about, let's say in this case, what I'm doing is having a setup, connecting, and what we did is, what if we have the Bazel profile, part of the execution log graph, and the EngFlow profile as a queryable data store? If you have that information already stored, what is going to happen is that you can do fun queries. And in this case, as you can see, I'm just authenticating into BigQuery. I'm just giving a window. And then you are going to be looking at something like this, which is regression detection, which I like it a lot because it's going to be looking at what is the median absolute difference across the things that we are doing, and why is this different to what you are normally using, is because it's looking at how your builds were behaving during the last 10 days or 2 weeks or whatever range that you decide. Then is looking at the median absolute difference so that you don't have the problem of outliers having skewed deviations, but you are looking at actually what is the baseline and like just removing the outliers from the build. And then you are going to compare that to the recent builds that you're having. So it's like, is there anything that is happening today? I want to be informed. I want to get an alarm. I want to get a trigger. Actually, I can go back to this one so that you see what I was looking for. So the slow builds optimizer was using the tools that I mentioned. Then it's going to be looking at the overview. So it's going to tell you, okay, this is the wall time, the critical path, the execution phase, the analysis, the remote actions. Is going to list all the things that are having here, whether or not they were a cache miss. And then here is going to tell you ranked base. Okay, here are the recommendations that I'm going to give you in order to optimize the build. So in this case, one very easy one was like, hey, why you don't do just charting of this one and then you cut the critical path? And then it's telling me how the fix actually looks like. The other one is fix the TypeScript project, cache misses, because we are having that extremely high. And then it's telling me also what is the root cause of that creation. So this is helping me on that level. And then it's giving me another information about the remote execution worker pool, because this was actually at full capacity in the moment that I was running. So it's not only about the build, but it's also about the cluster that you are running and just opportunities that you can make it faster. So this was pick it up basically live, so you can see the different aspects. And then it's basically ranking the different options that you have and what is the ROI that you have. So this is, let's see how the flame chart looks like. And hopefully it's going to look very similar to the one that I showed you at the beginning. Yeah, it's very, very similar. And this is the reason why it was slow. And this is the reason that we should be going and optimizing. Now, going back to Visual Studio that I just saw that the setup work, let me see if I can run the query that I wanted to show you. Because when you have a big repo, it's going to be very hard to get to the invocation manually. And even asking just show me the 10 is not going to be good. What if I run a query that returns these things? Like, show me the regression targets, and it's going to tell me, look, we move from just taking 1 second to 5 seconds or even more. This is the score, so you are basically going 85 times beyond what you were originally expecting. And then it's going to tell you more things about what is the optimization or the cost that you are wasting because of that regression. So if you can imagine you have your target pattern or you have your teams and you are running this query, you can immediately see, okay, what is going wrong during this week? So this is one way of looking at this. And I know in CI and dev and infrastructure, we love to be always negative on looking what is going wrong. But one of the feedback from one of our developers was like, why not bring in something more positive? Well, if you are working hard to optimize things, you should get recognized as well. So what about running most improved targets as well? So you have your team, you filter. So why not bring in the most improved targets? And when we talk about the most improved targets, and I just run it again, you are going to see that you can also find things like, okay, you move from this time to this time, and you are going to be presenting to your managers, look, this is the time that I saved. And if you have, because we have already the information, imagine doing this. You have the instance types that you were running, you have the total execution time that you were running, and then you just do a multiplication for the price that you are paying for them, and you are going to say, this is the amount of money that I just saved you, right? And this is an important factor because then you can get funding for the additional tech debt projects that you have been waiting for. So this is another area where you are looking and using the tools from Bazel to optimize. And when I say at the beginning triaging is because when you have so many targets, it's hard to know where to focus on. The two that I show you are basically for telling you if you invest time on these specific targets or these specific packages is where you are going to get the most out of it. And the same applies for these expensive targets, hotspot that I'm going to show you here, which is basically asking or resolving the question of, okay, where do I need to invest my time? In this case, is because of the miss hours, right? Miss hours is basically all the execution time that you use it, the total hours, and then you are going to say at the scale of Uber or any of the companies that are basically here, you can basically say that in a given day, you are spending months of execution time because you are running so many things in parallel. So this is basically some of the tooling that we have for analyzing, as I showed you before, another tooling that are related to how to triage, where to focus on, and other tooling just to celebrate that you made significant progress on what you were doing. And just because, I don't know, sometimes you need to report to managers in a better way than in a Visual Studio notebook, you can also go here. Let me select and open this generated report that you can say, okay, this is actually what is happening, right? It's more like you don't need to invest that much time. Everything was deterministic. You can go here and say, hey, this is how your team is looking like, so please fix it. Or you can say, this is why we need to invest more time on CI. Those are the time that we save. Those are the expensive targets. But also you can do nice things like this one, which is basically telling you by instance type, by action mnemonic, how you are basically using the resources of the company. In this case, you can see tastes are basically leading here, but you can use basically this for any action mnemonic that you have in your place. You use that for invocations, for failing, for anything. So it's about just the amount of data that you get from remote execution from Bazel is immense. But if you have a possibility to convert that information that is just traces scattered all over the place and make it into a configurable, a queryable data store, you can do the magic based on the knowledge that you have. That was it from my time, so thanks a lot for hearing.